and welcome to NASA's live coverage of the 2026 total solar eclipse. We're at NASA's Goddard Space Flight Center, and over the next hour or so, we'll be tracking the eclipse as it races across the North Atlantic and Europe. A total solar eclipse occurs when the moon moves between the sun and Earth and completely blocks the face of the sun, casting a temporary shadow on Earth. People located within the moon's shadow, also known as the path of totality, will experience a total solar eclipse. The sky will darken briefly as if it were dawn or dusk. So weather permitting, people in the path of totality will see the corona, the sun's outer atmosphere, which is normally hidden by the bright face of the sun. Today's total solar eclipse will sweep across Greenland, Iceland, northern Russia, Spain, and a small corner of Portugal. Many other areas in the Northern Hemisphere are already or will soon experience a partial solar eclipse, including much of Canada and parts of the northern US. And for many along the western part of the eclipse path, such as mainland Europe and Africa, the eclipse will occur early evening, creating a rare opportunity to see a sunset eclipse. Over the next couple of hours, we'll be bringing you live feeds from telescopes across Europe and hopefully views of totality in Iceland and Spain. Thank you so much to our partners, Time and Date, Southern Illinois University, and Exploratorium for those views. During today's show, we'll be joined by experts to learn why celestial events like these ones are important to study, document, and experience. And I have an important reminder on that note. When watching a partial solar eclipse, you must always use the right protection. You can use safe solar viewing glasses, like these ones called Eclipse glasses, or a safe handheld solar viewer like this, or you can use indirect viewing methods as well. Regular sunglasses, no matter how dark, will not work and are not safe for viewing the sun. So be sure to stay safe. Now, let's head over to my colleague Ernie Wright, who can tell us more about where the action is happening today.
Thanks, Joy. I'm standing in front of the map that I made for the eclipse that we're going to experience today. We're looking down at the North Pole here, and the red stripe is the path of totality. Those are the locations that will experience totality today. As we animate this, you can also see the much broader penumbra shadow. That's where the partial eclipse occurs. But here comes the umbra shadow. That's where totality is happening, inside that little oval. It passes over the east coast of Greenland, the west coast of Iceland, and across northern Spain, where, as Joy said, they'll experience an eclipse within an hour of sunset, so they should have lots of opportunities for really beautiful photographs. And then as the eclipse progresses and that umbra disappears, West Africa will also get an opportunity to see a partial eclipse as that penumbra shadow sort of slides off the edge of the Earth here. Now, as we zoom up and look at Iceland and Spain, Reykjavik is here in that southwest corner of Iceland. We're kind of crossing our fingers for them because it's a little bit cloudy there right now. That umbra shadow is traveling over 2,000 miles an hour as it passes through the path and crosses the North Atlantic. And then it runs into Spain here, where we expect more than 15 million people will be watching this eclipse. Some of them on the beach in Mallorca right before sunset, so they should get some really beautiful photographs over the mountains to the west. Now, the situation in the US is going to look like this. That yellow line is the southern limit of the partial eclipse. So folks south of that line, you're not going to see an eclipse today. But if you're north and east of that line, you may already be starting to see the partial eclipse. It takes 2.5 hours for that partial shadow to pass all the way across the United States. So it's not like totality. You don't have to run out there at the exact moment. Some places will have a partial eclipse that lasts for almost 2.5 hours. Others, maybe just an hour. So this is the situation right now. Montana, your eclipse is over. The shadow is passing out of North Dakota, but Minnesota, Wisconsin, Michigan, you're in it. The Northeast is also in it. And for folks in the Mid-Atlantic, you will be in it soon enough. Now, before you run outside to look at your eclipse that's happening right now, we want to show you a short video about how to observe this eclipse safely.
If you'd like to find and explore the animated eclipse maps yourself, like the ones Ernie was referencing, safety instructions, and much more about today's eclipse, head to science.nasa.gov/eclipses. So next, I'd like to introduce our first guest here in the studio. We have Dr. Kelly Corrick, who is one of NASA's heliophysicists, who studies the sun and its effects across the solar system. And she's also studied the sun's corona in great depth. Thank you so much for helping us kick off today's coverage.
It's great to be here, Joy.
So let's talk about why we don't always see eclipses on Earth. We've got this awesome model here called an Ori. So using this, can we talk about their orbits and why we don't see it every month?
Yes, so here we have the sun, the moon, and the Earth. And as we move, we can see that the moon is not exactly on the same line that we have with the sun. So the Earth can view the sun pretty well, but when we get it to about here, we can see that sometimes, maybe a little further, sometimes it lines up perfectly so that we're able to have that eclipse. And that's when we have that eclipse. So that 5 degrees off ends up not having eclipse every new moon.
Okay. And so today's eclipse will travel across Europe for the first time since 1999. Yeah. Can you tell me, why does that region not experience eclipses as often? And what is it that makes this eclipse unique?
Right, so this eclipse is unique because of the fact that, A, it's near sunset. It's also the fact that Europe doesn't get as many just simply as to the location, and any place on Earth, really, it's about 300 to 400 years between the time you get eclipses. So there's a lot of ocean on the Earth that it just doesn't go over land. Plus, with the angle, it tends to move very quickly and pass in and out, so they don't get a lot of eclipses. And again, it's super special being near sunset, so being able to see a sun setting being eclipsed, it's going to be really awesome photos.
Okay. And I've also heard of eclipse seasons. Can you talk a bit about that?
Yeah, so an eclipse season, when an eclipse happens like this, that lineup means that you're going to see the solar eclipse, so either a partial, annular, or total, and then you're going to see a lunar eclipse about 2 weeks later. So in about 2 weeks, we'll be able to enjoy the orientation where the Earth is actually casting the shadow on the moon and having a lunar eclipse. So that's the eclipse season.
Oh, fantastic. And I know Europe is going to have another eclipse happening in 2027, which seems to be a lucky few years for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse, and actually the longest eclipse of the century. So it's going to be 6 minutes and 28 seconds, so that's a very long one. Great for scientific investigation.
Wow. And so eclipses can occur somewhere on Earth roughly every 18 months or so?
Yes.
So why is it that NASA continues to study solar eclipses?
Because every eclipse is a little bit different. The sun changes as it rotates or changes its 11-year cycle. The Earth and the area of the Earth that it covers is different. So we make sure that we study it each time.
Fantastic. Thank you so much, Kelly.
Thank you, Joe.
So throughout today's coverage, we'll be joined by other NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities you're hearing about today. You can ask your questions in the chat on YouTube, Facebook, Twitch, and Instagram, or tag @NASA wherever you're watching. We also have questions we want to ask you today. So if you want to head over to NASA's Twitch or Instagram stories and take a look at the poll we've got for you, you can participate and answer those questions. And so before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. We'll have 2 different countdown clocks displayed over the course of the next hour that will let you know how close we are to the first instances of totality in the telescope views we have in Iceland and Spain, respectively. Those are the 2 locations where we hope our telescope partners will be able to capture the best views of the sun being totally eclipsed by the moon. We're tracking totality in Reykjavik, Iceland at 1:48 p.m. Eastern Time, or 5:48 p.m. local time, and that will last about a minute or so. And then we're going to set our sights to Leon, Spain, for totality there at 2:28 p.m. Eastern Time, or 8:28 p.m. local time. And the eclipse there will be about 2 minutes long. So there's a lot of science taking place during those fleeting moments of totality today in Iceland, and we have experiments on the ground and in the air. And in the view looking at right now, there's a camera that will be capturing the view of the sun's corona when it's time for totality. When totality hits in Iceland, the planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona, where the skies will hopefully be clear up there. The plane took off from Keflavik Airport about an hour ago, and then we're going to be talking to the science team live from Iceland very shortly. Before we do that, let's learn more about what it's like to be a NASA pilot in those eclipse experiments.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer by trying to outrun the moon's shadow with an airplane.
The truth is, it's actually chasing us. We get out in front of it and let it overtake us. Once we're in totality, then we'll advance the throttles to max and try and stay in totality for as long as we can.
Making that happen takes extreme precision. Scientists calculate exactly where the airplane needs to be at each moment.
We do a lot of missions where being in the right point in time and space are critical, and this is one of them.
On Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
Viewing an eclipse from 50,000 feet provides a really clear shot of the sun. And that allows the scientists to have confidence that the data that they're seeing is from the sun rather than distortions from the atmosphere.
When the moon's shadow arrives, it engulfs the aircraft.
It's weird. Right where you're at, it's dark, but everywhere you see it's twilight. And the temperature in the cockpit drops, so it's very noticeable.
As the eclipse unfolds, the pilot keeps the aircraft on course, while the sensor operator fine-tunes the cameras, capturing every second of data.
You're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
For the aircraft crew, it's a chance to witness one of nature's most spectacular events while helping scientists better understand our sun.
I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today. For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the sun's corona. To learn more, let's chat with Principal Investigator Amir Caspi, who is chatting with us live from Keflavik Airport in Iceland. Hi, Amir. Thank you so much for joining us today.
Hi, Joy. It's a pleasure.
So firstly, how are you feeling right now? And can you tell us what experiment you're doing today?
Yes, well, feelings are mixed today because, as you can see behind me, the sky is not very great for those of us here on the ground. On the other hand, we have an airplane that's now cruising at 50,000 feet above sea level that's preparing to observe the eclipse in just about 14 minutes. And we are going to be imaging the solar corona with an instrument that has 4 cameras on board with observations ranging from visible light through near infrared all the way to the mid-wave infrared, which we often refer to as the thermal infrared, to make new observations of the corona and learn all about coronal structure and dynamics.
What is it about the corona, the sun's outer atmosphere, that we're still trying to better understand?
Well, you know, we've known for about 100 years now that the corona is incredibly hot. It is millions of degrees hot, even though the solar surface is only a few thousand degrees. And we're still trying to understand exactly how the corona's magnetic field carries that energy up from the solar surface into the corona to heat it to those high levels. Our observations today will open new discovery space with wavelengths that are very rarely observed, that will allow us to apply physics models to better understand how that corona is heated. We'll also be looking at the structures of prominences or material from lower down that's kind of suspended in the corona that we're still trying to understand, especially in these infrared wavelengths where we don't have a lot of observations. And all of this will also help us to understand, of course, the sources of space weather that affect us here on Earth.
And so I know you flew this experiment and a similar one during the 2024 and 2017 total solar eclipses. What did you learn from those eclipses? And are you making any changes to your experiment for this eclipse?
In 2017, our first attempt at this kind of observation, we didn't even know what we were going to see. And measuring in the midwave infrared revealed new observations and new measurements that I think opened up the possibilities of lots of future experiments to try to better understand this emission from the sun. In 2024, we flew an upgraded instrument, the same one that's flying this year. It has 4 cameras measuring across 9 different wavelength bands. And we learned quite a lot, although we're still analyzing that data. So I don't have any results to share with you right now, except to say that we saw some amazing structures, and it'll be very interesting once we complete our analysis.
Yeah, I'm looking forward.
For this year, we're flying the same... Oh, sorry, go ahead.
No, go ahead.
For this year, we're flying the same instrument, and we're not making any changes to it from 2024, except that we're applying all of the lessons that we learned from the prior flights, including being able to fine-tune the observing time and the observing procedures. And of course, we also now have our data analysis pipeline that's already made from 2024, which will allow us to combine this data with the data from 2 years ago to make new scientific measurements much faster than we were able to do in the past.
Thank you so much, Amir. I know the plane is about to be capturing the eclipse in about 13 to 14 minutes. So best of luck out there, and thank you so much for joining us.
It's my pleasure. Thanks so much.
So let's take a look at the telescope views right now. The partial solar eclipse has just begun in Spain. You can see a little slither of the sun that's been cut off on the one of the sides. The moon has just started to move in front, and will take roughly an hour or so before it completely covers the bright disk of the sun. Thank you again to our partners for these beautiful telescope views of the solar eclipse. We're about 10 minutes away from totality in Reykjavik, Iceland. The telescope views there are cloudy at the moment, but what we're seeing in front of us are views from Spain, and hopefully the skies stay clear for Spain. And fingers crossed, that is what we want for a total solar eclipse, is clear skies. So before totality comes, we have a few minutes to show you different types of science NASA has been conducting in Iceland for years. Iceland is a great place for astronaut training due to its terrain. A few years ago, the Artemis II crew and the science team spent some time there to prepare for the Artemis II mission. Let's learn more.
Iceland is a really wonderful place. It's a great place of interest for geologists, but it's also a wonderful analog. On Artemis, we'll visit the lunar South Pole, we'll make observations from orbit, and we have a whole new set of science questions that we hope that Artemis astronauts will help us answer for the Moon and Mars, which are, of course, planetary bodies we're really excited about for human spaceflight. Specifically for the Moon, we have features here in Iceland that are geologically relevant to the Moon, and also just have a sense of scale and a sense of identity that really mimic what we know the lunar surface looks like. There's a reason Apollo astronauts trained here, and there's a reason we're bringing Artemis crew here now. This is just a really wonderful place to learn about processes that shape the Moon, and to really understand what it feels like and what it takes to actually navigate and do an EVA or a spacewalk on the lunar surface.
In Iceland, we are doing field work. We're training crew members. This is a key location for training for Artemis crews. Here we see in real time time volcanic features that were created not long ago. It's a real special place for doing training for geology. I'm here in Iceland training the Artemis II crew in geology. There's really transformational science that we can learn by getting boots back on the moon, getting samples back, and being able to do field geology with trained astronauts on the surface, making observations that only they can make from that perspective.
Everybody start to see maybe softball size, like.
It's a fantastic place here in Iceland to be able to train geology. Also, navigation skills are another big component of what we're doing out here in a beautiful environment like this, out here camping in the highlands of Iceland.
Wow, what an office to work in. So later on in our coverage, we're going to be taking a closer look at the student ballooning experiments as well. And that's been taking place in Iceland for the past 24 hours. But now we're going to be chatting with Marie Henderson, who is the Artemis II Lunar Science Deputy Lead. She has experience training in Iceland and has a key role in the Artemis II Lunar Flyby data collection. Marie, thank you so much for joining us.
Thank you so much for having me today.
So during the Artemis II mission, the astronauts were lucky enough to see a total solar eclipse from space. Not to be corny, but that's what I call sun and moon joy. Was that something that was planned from your side?
We knew that it was a possibility that we could have a solar eclipse during our lunar flyby. So months before, we prepared our lunar imaging procedures, some of that based on what we learned during the Apollo program, but also some that we learned from imaging that took place during the 2024 solar eclipse. And so we used that to prepare our cameras, but also once we realized we were coming up on a launch day, especially in April, where there was that possibility, we had to go back and we had extra time to train the crew on what they were going to be seeing during this eclipse and what types of observations the scientists were really excited to learn from them for.
Wow, what a lucky alignment of stars.
Yes.
Is seeing an eclipse from space any different from Earth? Did they see different things, and did they have to wear eclipse glasses?
Yes, the crew did have to wear eclipse glasses, and so we got those manifested, as you can see on your screen, for them to make safe observations. One of the large differences between what the crew saw as they went around the moon and from here on Earth is we looked at an eclipse through Earth's atmosphere, and so they didn't have to look through an atmosphere as they're going around the moon. So they're able to see the full extent of that corona as well as the zodiacal light in the solar system.
And how long was the eclipse up there?
It's about 53 minutes long. So
wow.
They got a much longer chance to look at that eclipse.
Wow, what an opportunity. What was the day like for you in the SUR?
It was a very exciting day. This was not something that we really knew exactly how it would be. And so we had just had a beautiful lunar flyby of the illuminated portions of the moon, and then we turned to watch this eclipse. And the descriptions that we heard coming down saying that they were, this is sci-fi, and they couldn't even imagine, and this glow, we didn't see that in our coverage, but once those images started coming down that night, it was mind-blowing to see exactly what they're describing, and I wish I was there myself.
Same. Well, that's incredible. So Artemis II has just launched, and so we have Artemis III to look forward to. Can you tell me how you're preparing for that mission?
Yeah, so Artemis III is a different type of mission. We're not going to be going to the moon. We're actually going to be working in Earth orbit. And so this will give us an opportunity to test our human landing systems, which will be the spacecraft that we take down to the surface of the moon. And so we'll work to hopefully dock with one or both of the human landing systems. But we're also going to have an opportunity to do a lot of science at Earth, because this will be a new, unique viewing orientation as well.
Wow, what an exciting few milestones to look forward to. Well, Marie, thank you so much for joining us today.
Thank you so much for having me.
So if you've just joined us, take a look at these maps that we're showing you right now that's showing the path of the moon's shadow. You can see that it's close to reaching Iceland. We're about 5 minutes away from totality in Reykjavik. And over in Spain, you can see that we have about 45 minutes left until totality reaches them. So these are views from Villabado in Spain that we're seeing right now. And if we switch back to the map, you'll see that the moon's shadow actually looks pretty slow as it's traveling across down towards Spain, but it's actually traveling at over 2,000 miles per hour. These maps were made by my colleague Ernie Wright, who used various NASA satellite data to create super accurate maps for us. If you want to view and download them yourselves, you can visit science.nasa.gov/eclipses. So now let's welcome back NASA heliophysicist Dr. Kelly Corrick. Kelly, how are you feeling about today's eclipse?
I'm excited for everyone, and I know those clouds are a little worrying in Iceland. That's one of the reasons we had the plane, but also joyful to see the balloons that are going to be launched, as well as seeing it in Spain. So really excited.
Yes, and I'm sure the NASA pilots must be excited as well on the plane.
Yes, exactly. It's a great view. It really is a great view from that.
So here we're seeing a live view from the WB-57 aircraft sensor right now. They're moments away from seeing the moon's shadow hit Earth and also chasing the eclipse. And we haven't actually seen the view of the corona yet from the nose, but they will be capturing images once totality hits Iceland. And on the right-hand side, we're seeing a partial eclipse from Norway, which is really exciting. So we have places across Europe that will be able to witness a partial solar eclipse. There'll be many, many people here that will be able to experience this amazing celestial event. So let's see how many. We're about 6 minutes away from totality in Iceland.
Yeah.
What do we expect to see right before totality?
Right. So right before totality, we're in that partial eclipse that's going deeper and deeper, and you start to see things go dark. So even if there are clouds, it's going to get a little bit darker. The weather is going to drop too, because again, you've blocked out some of the sunlight, so you're going to get cooler. There's some wind that'll pick up. So the eclipses are really full body experiences. You might also notice that animals react as well. It's not just humans that experience this, but if there are any animals, they might start to pretend that it's nighttime or realize it's nighttime and start to kind of nest. And this is very unique for that part of the world because right now they're on almost 24 hours of sun. So they are going to be a little shocked by this. And so you'll be experiencing a lot of different things, even if you don't get to see the beautiful corona.
Yeah, I'm thinking about everyone on the ground in Iceland right now. They may be seeing clouds, but can you tell me, how does the climate shift when an eclipse happens? Because I've heard that the weather can change drastically.
Definitely. So from personal experience, in 2017, I was in South Carolina and there were thunderstorms. And during totality, it parted just around the sun and was able to actually fully enjoy the eclipse and see my first total. That was my first total solar eclipse. So there is hope that the clouds are influenced by that change in day-night, that eclipse that's coming through. So we're hoping that some of the winds and some of that changes could change things for Iceland.
Okay. So we're seeing right now on screen a live telescope view from Spain, and that's because the telescope views in Iceland are obscured by clouds. But as Kelly mentioned, I'm hoping that the clouds will part and the weather will change for them. Anything can happen at this point, right?
Right, anything can happen. And also, we'll talk about it a little later, but the balloon experiments, they are testing the atmosphere. The atmosphere of the Earth is still being affected, even if there is cloud cover, and that helps us with predicting weather models. So it's not just about the coronal science, which is something that I'm very passionate about, but it is also about understanding our planet and how it interacts with the sun and the light that we're getting from it. And you see, we're starting to see something in the WB-57. It's getting very close. They were zooming in there, so that's
okay. Oh, wow. Okay, so everyone who's watching right now, the right-hand box, you will see the live views from the WB-57 aircraft. That's where the NASA pilots are chasing the eclipse from the skies. So Kelly, can you tell me what are the benefits of observing the eclipse from up there?
From observing up there at 50,000 feet, wow, okay, so I'm looking at these are great. 50,000 feet, you're able to get a above all the clouds. So they're above all the clouds, and we're able to, again, allow it to overtake us, so they get a few more seconds of totality. You saw that beautiful pink filament on the sun. That is something that Amir talked about, is that filament, that material that comes off the sun that can actually create space weather and affect our power grids here on Earth. It can affect our GPS. So if you ever use your maps to get anywhere, that's something that we need to understand and be able to predict. It also affects our astronauts, our dear astronauts, so making sure that they're okay. So those things are really important to study, and one of the reasons why we have the WB57. It's a little hard to see, but in the words on the right-hand side, you see that pink filament now on the WB57 feed, which is on the right-hand side. And yeah, so you can see it in the NVIS area, now kind of right in the center. You're seeing that prominence, and so this is amazing data. And it might not look as crisp as we're used to. You know, we're used to 4K down here, but this is really data a scientist can love, because this is telling us very specifically about part of the data. So it's like taking only a little part of the TV stream in and really getting the information about the iron or the oxygen or the specific composition of what that's made of. And if we know what it's made of, we can do more science with it.
So we're about like a minute and a half away from totality in Iceland. And so we have a minute and a half for the clouds to pass. So the sun view that you're seeing here, that is not of Iceland, but that is of the partial eclipse in Spain. Iceland is still being covered with clouds, but totality will hit them in about just a minute or so. And luckily, our airplane, the WB57 aircraft, they're going to be getting clear views of the eclipse from the skies. So we're going to be seeing what the camera on the nose of the plane will be seeing in roughly 1 minute, which is so exciting for them.
So exciting, yes, definitely. And you are starting to see some of the what would be a diamond ring effect. So those little pink things that you're seeing, this is happens when light passes through the valleys of the moon. So you don't have a perfect circle on the moon. It has those craters, and there's that diamond ring effect.
Oh, wow.
So yeah, so just absolutely beautiful. And that's when you still should have your glasses on. And when that ends, that's when we're able to do it. And I want to comment, this is an experiment, right? And so this is part of the reason why we're seeing kind of the arrows or the crosshairs go in and out. We are real time. This is real time live.
Yeah.
How science happens is that we are trying to make sure to make adjustments and make sure we're getting an image.
Wow.
Yeah.
So we are 7 seconds down to totality in Iceland. This is really exciting. We're getting a shot of the ballooning experiment as well. This is the nationwide Eclipse ballooning project. They've been launching balloons for the past 24 hours leading up to this eclipse, which is so exciting. And I can see that they're getting really excited as well, despite the clouds, because they can actually still collect data even though they can't see the eclipse. Is that right?
Exactly. They can still collect data. They are still experiencing a little bit of that darkness. It's obviously darker. See, it's definitely darker, even though you can't see the corona itself. Yep. And a little bit looks like sunset around the 360 degrees. And you know, hopefully we'll see this in Spain, where it'll be very vivid imagery there.
So it looks like totality has hit Iceland, which is so exciting. You can see that the ballooning team is engulfed by darkness here. So that is so exciting. I can see them smiling. Oh my goodness. So why do we see a 360-degree sunset during an eclipse?
Because there is light on either side. It's just simply blocking out in that specific shadow. So it's like the sun has gone down just in that one location, but you know, the rest of the Earth is still illuminated. So you still have oh wow, that is images of the sky and the airplane. We are seeing the airplane.
Wow, so we have experiments happening in the air and on the ground in Iceland, which is so exciting.
Definitely.
Wow. So, and then what we're seeing now is the partial eclipse happening in Norway. They will just be experiencing a partial, but in Iceland, they are experiencing totality right now. We have experiments, balloons capturing data in the skies, and also a plane capturing data in the skies as well.
Yes, we do. And it's really interesting looking at the sun. There are some features, those lines that you see, the dark lines, those are magnetic features, and those again are the exciting things we want to know about for space weather, and so to better understand that. So the sun has given us some very interesting things to look at, and those experiments will really, really help us.
Yeah, and so this is why Eclipse observations and eclipse chasing is so critical, because even though they happen often and even though we know exactly when they're going to happen, you never know when the weather will just obscure your view. So we want to take every opportunity we can to get observations.
Definitely.
So, okay, so if you were in Iceland and you were either seeing clouds or you were able to see the eclipse, please share your experience with us. We want to know what you experienced on the ground. Please tag @NASA wherever you're watching. So we have a lot of questions coming in here from social media. So Kelly, shall we dig into those questions?
Yes, let's dig in.
Alrighty, so we have Bo on Facebook and they ask, are we really going to lose gravity during the eclipse?
No. We are not.
Okay.
Gravity, really, the stuff that sticks us to the Earth's mass has not changed because of this eclipse, and so we're going to stay grounded on this Earth.
Okay, noted. Gravity will not change. Okay, so we have another question from X, and they ask, how much can we actually learn about the sun during just a few minutes of totality compared to years of normal observations?
It's really about having all of the observations, right? We definitely need that totality because the moon just happens to fit so perfectly over the surface of the sun that we can see from that surface outward for that space weather, whereas some of our instruments aren't quite that close in. So we need to knit them together and use both the couple of minutes from the eclipse as well as the years of observations from our NASA satellites.
Okay, well, I'm glad that we have both ways of getting observations.
Exactly.
So we have another question here from Elinu on YouTube, and they ask, why does the weather change in a solar eclipse?
That's a good question, and I think that's something still trying to be understood. But if you imagine you've stopped heating something up temporarily, so things sink, right? When things get cold, they tend to sink, and so the air is moving, and there starts to create winds. And when you create winds, you start to cool things down. So the weather changes due to just turning on and off the light alone, because the sun is so important to us in actually regulating our weather.
Wow. Okay, so we have another question here from Frank Perez on X, and they ask, for sending teams to do research in the path of totality, how do you balance the crew training value of Iceland's terrain against the statistical odds of clearer skies in Spain?
And we definitely addressed both, right? There are great things to do with the atmospheric work, especially in the Arctic areas, for the balloons that we sent to Iceland, and then we have teams in Spain also doing that. So it was a balanced portfolio. We made sure that we had both types of experiments available.
Okay. Thank you so much. So keep your questions coming in. We'll be answering more later on in the show. And so earlier, I also mentioned that we had questions for you, the viewers, as well. You can head over to NASA's Twitch and Instagram to weigh in on a couple of those. So here are some of those questions that we posed to you. So Kelly, let's see what those questions are.
Definitely.
So if you had to pick where you'd watch the eclipse from out of these special locations listed,
yes.
I'm going to ask you this, Kelly. Which ones would you choose? So we have the International Space Station, a high-altitude plane, an observatory telescope room, and a NASA chase jet.
It would be a tough choice between International Space Station or high altitude plane. They've got such a huge overview. It's great.
Yeah, I think I would choose the same too.
Yeah.
So thank you to everyone who has participated so far. We're going to check back into those results a little bit later on. So next, let's head back to the ground in Iceland. We have another NASA-funded experiment there involving balloons. Students that are part of the nationwide Eclipse ballooning project. They've been launching balloons continuously throughout the eclipse, and we're going to be chatting with them live from Iceland shortly. But first, let's learn more about their Eclipse project.
Teams of students from across the United States have a unique vantage point of total solar eclipses, thanks to scientific balloons.
The Nationwide Eclipse Ballooning Project is a NASA mission-like adventure in collecting data from balloons that go high up into the atmosphere.
Started in 2014, the project engages college students and high schoolers in one of two distinct paths.
One is the engineering track that has mostly engineering students that get to tinker on different payloads. And the other track is an atmospheric science track where they'll actually be launching weather sensors to study the impact of the eclipse.
Atmospheric science teams launch helium-filled weather balloons, the same as those used by the National Weather Service, every hour for hours before and after an eclipse. Engineering teams fly larger balloons laden with cameras and experiments they build themselves 100,000 feet up into the stratosphere. From there, they study a variety of things such as incoming cosmic radiation and ozone levels, as well as offering dramatic views of the moon's shadow on our planet.
The project is really a unique one in that it's both an education, but also doing amazing science that's both about the eclipse itself and also the atmospheric response of the eclipse.
Student balloon teams made a historic first during the 2019 eclipse. They measured eclipse-driven atmospheric gravity waves in Earth's stratosphere, or large ripples in the air caused by the temporary cooling due to the drop in sunlight.
What excites me the most about this project is thinking about the experiences that the students have that they'll remember forever.
Talking to us live from Mosfellsbæ in Iceland, we have Jared and Tessa, who are part of the nationwide Eclipse ballooning project. Jared and Tessa, thank you so much for joining us. I know you just experienced the total eclipse in Iceland. How was that for you?
It was awesome. I mean, it's definitely cloudy here, which is a shame, but we saw the lights dim. It was almost as if you were indoors and it was just, you were dimming the lights. It was almost instant, which is, I've never been in the path of totality before, so I've never seen anything like that. So it was really amazing.
Yeah, the wind totally stopped. It was windy and then it just stopped. The birds, we had birds flying over us all day and then they just disappeared. So it was a little eerie, kind of creepy.
Wow, that's amazing. I'm so glad that you could experience that, even though, you had cloudy skies. So tell me more about what you've been doing. I see you've got balloons launching in the background. What are you measuring with the balloons in Iceland?
So we have 7 balloons that are measuring a lot of different things like temperature, pressure, humidity, wind direction, and speed. And this is supposed to gather the atmospheric changes during the eclipse. So normally during the day, air rises until it hits less dense air, and this is called the boundary layer. But during nighttime, when the sun is down, this air stops, and it's called boundary layer collapse. So that's exactly the same thing that happens during the eclipse, and we're using these radiosondes to measure the atmospheric changes, the boundary layer collapse, and then the recovery. And we're in Iceland not just because it's in the path of totality, but also its northern latitude and its shorter nights make a completely different boundary layer. So it's been a really cool opportunity to be able to study that under the eclipse, under this unique conditions.
So you're both college students right now. How long have you been part of the project, and what made you want to join the project?
Yeah, so we started this project at the beginning of June. So we've been working with our teams, respective teams, Tessa at the University of Kentucky, and then my team made up of students from across Idaho. And we've been meeting once a week, doing balloon launches, preparing, and really what got me into it was my ballooning club that we have at the University of Idaho, and we all just, we love the science, we love the teamwork, the team building, and so it's been a lot of fun.
That's great. And so do you have any tips for students who are thinking about joining?
Yeah, so my biggest tip would be to get involved. That was how I learned about this project, was through my club. The professor came to us and was like, hey, there's this really cool opportunity, and so you guys should put an application in. And then also just, what if you have internship opportunities and you see those, just put an application in. You never know what opportunity you could get.
And then also, I would say, if you have a class that you're really interested in, just talk to the professor, see if they need any help on the research, because it really gives you a good opportunity to apply your classroom knowledge to real life scenarios, which you don't usually get in the classroom. And you also never know what opportunities will arise, like going outside the country for the first time, like I'm doing right now. So, yeah.
Oh, wow, that's amazing. Well, best of luck. I know you're launching continuously after the eclipse as well. So thank you so much for joining me, Tessa and Jared.
All right, thank you.
So the nationwide Eclipse ballooning project are also launching balloons in Spain as well as Iceland, and I can't wait to see their observations. So if we head back to the map, the moon's shadow is heading towards Spain right now, and we're roughly half an hour away from totality in Leon, Spain. For this eclipse, the moon's shadow is roughly 182 miles wide at its maximum width, and it's traveling at over 2,000 miles per hour. And so here we're seeing eclipse views as well in the bottom corner in Leon, Spain. And you can see the little bite that the moon has taken out of the sun, and we can't wait to see totality there. It looks like they have clear skies, which is awesome. And so if you are watching the solar eclipse from the ground, remember to wear safe solar viewing glasses or eclipse glasses, like these ones here. The only time you can take them off is during totality when you're experiencing it. If you're watching the partial eclipse in the United States, you can wear eclipse glasses the entire time. If you want to learn more about eclipse safety, head to science.nasa.gov/eclipses. So total solar eclipses give us a chance to study the sun's corona in greater detail, which helps us learn about how it behaves and affects us here on Earth. The sun is highly dynamic and creates conditions in space called space weather that can affect our technology, from GPS systems and communication satellites and airplanes and even our power grids on the ground. But in order to better understand it, we have a suite of spacecraft that are monitoring the sun from different vantage points around the clock. So let's learn more about NASA's space weather program.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the Moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
If you're just joining us, welcome to NASA's live coverage of today's total solar eclipse. We're roughly about 25 minutes away from hopefully seeing the first instance of totality in Spain. So stay tuned for that exciting moment. And so joining me in the studio now is one of NASA's space weather analysts, Karina Alden. Karina, thank you so much for joining me.
Thanks for having me.
So your role involves monitoring the sun in real time. Can you talk a little bit about what you do?
Yes, of course. So what we do is we basically observe, model, analyze, and then we document it. And so what we're observing is usually those coronal mass ejections, or as I lovingly like to call them, sun burps. And we're measuring those, seeing where they go, and then we're modeling them to see what NASA missions or possible planets they impact. And then from there, we're documenting it and notifying NASA missions about potential impacts.
And so we just learned a little bit about NASA's space weather program. Mm-hmm. How does monitoring space weather affect the everyday person?
Yeah, so most of the time the everyday person is going to see it in terms of northern lights, but what we do also see is some of that impact to the GPS as you're navigating. Sometimes it'll be a little wonky and you don't really know why, but that could possibly be due to some solar storming happening. And then we may also see some impacts to agricultural folks who are using tractor precision farming.
And so back in 2024, we saw these huge solar storms. Can you tell us how that storm affected Earth and if we had to mitigate any of those effects?
Yes, so along with NOAA's Space Weather Prediction Center, we did have to do some mitigation, but honestly, my favorite part was seeing the Northern Lights. And so 2024 is when I first got to see the Northern Lights. I saw them in August, and then you're seeing a picture that I took on my phone where we saw them here in Maryland, which was absolutely incredible. And you can see a picture of the team that I work with, the Moon to Mars Space Weather Analysis Office, along with some of the Heliocomms folks, where we got to see it down here in Maryland, which is absolutely incredible.
Amazing. And so I know that you were also part of the team that monitored space weather 24/7 during the Artemis II mission when we flew astronauts around the moon. What was that experience like?
Surreal. I mean, it's very odd to be staring safely at the sun via satellite imagery, but not see it in person for an extended period of time, because I was working the overnights, but it was incredible, and I loved seeing the solar eclipse from space. I think if I were to do it, I'd want to be one of those astronauts.
Absolutely. Well, thank you so much for joining us, Karina.
Thank you.
So next, let's hear from NASA Administrator Jared Isaacman and Head of NASA Science, Nikki Fox. My colleague Jasmine Hopkins caught up with them a few days ago to talk about why this celestial event is so important and what the 2026 eclipse can teach us about the sun.
Today, I'm thrilled to talk all things eclipse with NASA Administrator Jared Isaacman, who's leading our vision behind science and why eclipses are so important, and Dr. Nikki Fox from our Science Mission Directorate, who will tell us what exactly is going on with the sun during an eclipse. Are you guys ready to talk?
Absolutely.
Okay, fantastic. Our opening question is for both of you. Just a couple months ago, we wrapped up the historic Artemis II mission, and now we're on the cusp of a total solar eclipse. Can you describe in one word how you're feeling right now?
Excited? He took my word.
Okay.
Excited is the right word, because when you saw that total solar eclipse from Artemis II, it was so spectacular and nobody was ready for it, even people who see total solar eclipses all the time. And so when you saw that, it just brought the beauty of space and the beauty of the science we do into such clarity.
I think NASA is one of the only places where we can see a solar eclipse from down here on Earth and then from the other side of the moon.
We study the sun all the time. It's one of our main things that we study in NASA science. We look at it in all different wavelengths. We look at it from all different vantage points to be able to predict when these really large radiation storms are going to come towards our planet, because we want to make sure our astronauts are safe. The eclipse just gives us even more opportunity to study that sun just a little bit more, to really make those big breakthroughs to keep our astronauts safe.
All right, next is for both of you. If you could witness a solar eclipse from anywhere on Earth, where would you choose?
Anywhere that doesn't have clouds. Having been clouded out for the last eclipse, I will say I will go anywhere that there's no clouds.
Look, Iceland is very cool in Spain, a lot of the observation locations for this one, but in Egypt, in the Valley of the Kings, is going to be an amazing backdrop.
And that is going to be the longest total solar eclipse of the 21st century. It is over 6 minutes. To stand in somewhere ancient is particularly moving.
What's the one thing you want people to walk away understanding about why studying eclipses matters?
I think these kind of magical events, I would very much describe that eclipse as a magical event. Maybe it creates a spark in who knows how many people around the world to look up, imagine what's possible, and then grow up and start contributing in this great adventure that we're on.
Remember that Einstein confirmed his theory of relativity using an eclipse. Eclipses are very powerful. You see stars, you see constellations, you see planets that you don't normally see. It kind of reminds you of our place in the universe.
Why do we still care so much about the sun? Is there anything new we can learn about it?
There's always new stuff to learn about the sun. It is our star, but it's the only star we know right now that has the responsibility for maintaining life on a planet. And as we sort of continue to try and answer the question of, are we alone in the universe? Understanding our relationship with our sun is so important, and eclipses give us that opportunity to do that. It is honestly the only time that we can really observe some of the phenomena, particularly down low in the chromosphere, really looking at how the corona turns into the solar wind. It bathes all of the planets, but we live in the atmosphere of the sun. So when you get these big events, they can cause havoc for technology here. And of course, our prime thing, keeping our astronauts safe in space. So understanding our sun is more critical today than ever.
Thank you both so much for being here today. Really appreciate it.
Thank you.
Thank you to our NASA Administrator, Jared Isaacman, and Head of NASA Science, Nikki Fox. Let's head back to Ernie right now, who is going to dive into our eclipse maps and where the eclipse is heading next.
Thanks, Joy. It's so exciting for me to watch this eclipse progress. I mean, we can predict these, but you really can't anticipate how you feel about them until you see them. So I'm standing in front of the eclipse map, and just to recap, this red stripe is the path of totality. Those are all the locations that can experience totality. You're seeing the partial shadow emerge from northern Siberia. It has already crossed Alaska. It's over Canada and the northern United States right now. And that little oval is the umbra where totality is actually taking place. It has just passed by Iceland, and although it was cloudy there, people got to experience the secondary effects of an eclipse where you get the darkening and the brightness along the horizon. And it will very soon be over northern Spain, where we expect more than 15 million people will be watching the eclipse. Toward the end of it, partial eclipse in Western Africa. So this is a close-up view. Reykjavik is here. They unfortunately had clouds, but the WB-57 was flying just above that. And they were there because that's kind of the spot that if you're on the center line, you get the longest eclipse of 2 minutes, 18 seconds today. And we're just a few minutes away from seeing totality pass over Spain less than an hour before sunset. That should produce some really beautiful photographs, especially for folks on the beach watching this over the mountains to the west. This is an unusual eclipse. It's kind of weird. And one reason for that is where the total eclipse starts. This is the Timir Peninsula in northern Siberia. And because they're so far north, that eclipse starts at midnight. They are well above the Arctic Circle, so the sun is up 24 hours a day. And then the other kind of odd thing about it is this north-south path. Most eclipse paths, most totality paths, are west to east. But this one, because it's so close to the pole, and because of the orientation of the Earth and the fact that it's a descending node eclipse, it's starting in the north and going to the south, and then suddenly making this left turn into Spain. So we're looking forward to seeing that total eclipse in Spain, where the weather looks great. Back to you, Joy.
Thank you so much, Ernie. So we're about 15 minutes away from totality in Spain. The view we're seeing here is from Leon, Spain. And I want to say thank you again to our partners, Time and Date, Southern Illinois University, and Exploratorium for providing these stunning telescope views of the solar eclipse. This is really, really exciting. They have 15 minutes left until the sun is completely obscured. Luckily, Earth is not the only place you can experience a total solar eclipse. Our astronauts on the International Space Station have witnessed several solar eclipses from this very unique vantage point. So let's learn more from my colleague Abby Unterante, who caught up with the astronauts on the space station a few days ago.
Well, hi, Jessica and Anil. It is so great to talk with you. From the International Space Station, you see Earth and the solar system from a unique perspective every single day. Thank you so much for joining this long-distance call to talk about this moment.
We're so happy to share this with you.
We study the sun and its influence on Earth and throughout the solar system through a field called heliophysics. What is the benefit of studying the sun from up there in low Earth orbit?
One of the big things is that there is a lot of particles that are around Earth, and those particles can be affected by coronal mass ejections, and those ejections can energize the particles and affect things that are in space. And the things that we care about in space are satellites, and those satellites give us communication, they give us internet, and so there's even a future where we have data centers in space, and we're using the sun's energy to power things like artificial intelligence and things like that. And so we need to understand how that's going to be affected by the sun.
If you could pick anyone, who would you want to watch an eclipse with, and would you rather watch it from Earth or from space?
This one for me just reminds me of one of my mentors from graduate school, Jerry Koyman, and he and his wife, they are eclipse chasers. So I think if I could share it with one very special person, somebody that played such a role in inspiring me and helping fuel my scientific curiosity and helping me be a successful scientist, it would be to watch that with Jerry, and it would be to watch it from up here, because I know he has never seen one from the International Space Station.
I was going to say something similar. I would love to watch it with my kids because it was such a unique experience for me. When it happened, the animals, the birds got quiet, it got dark, it almost felt cooler, and I think they would really love it.
Endel, I know you just arrived. Is there anything that you've seen out of the cupola or the wharf that surprised you since you've arrived?
Here's the most surprising thing. On the launch, you have a chance to look out of the window of the spacecraft as it's docking with space station. And when I looked out the right window, I saw this bright, shining thing, the International Space Station. I knew it should be there in space, and we were tracking it, and a lot of people did all the math and engineering to get us there, but it just was something that was just hard to comprehend at the same time, and utterly beautiful. It's this merger between art and science.
The best part about that moment was we were all inside the space station, very anxiously awaiting Anil and Pyotr and Anya's arrival, and we could hear the communications coming from the Soyuz. The Soyuz was, of course, talking to the ground. All of a sudden, we heard Anil's voice, and he said, "I see it! I see the space station!" It just made everybody smile and made everybody so happy, because we remembered that moment for ourselves when you see it for the first time, and it doesn't even look real. It looks like a little computer animation or something, and it's so small, and then it just gets bigger and bigger and bigger, and then suddenly it becomes your new home.
Thank you so much. It has just been a pleasure to speak with you both. We really appreciate you taking the time.
Thank you, Abby. It's been wonderful speaking with everyone today, so keep looking up, and we'll be waving at you.
So at last report from Mission Control, Jessica, Anil and the rest of the crew had their eclipse glasses on standby, just in case the space station path brought them any unexpected views. So we'll keep an eye out and see if they saw anything. But we did just get something new come in. So a short while ago in Hodgdon, Maine in the US, one of our NASA photographers actually caught the International Space Station flying across the sun during the partial eclipse. Let's take an exclusive look at that image. Wow, that is an incredible shot. So this was taken by Joel Kowski with NASA headquarters. So in the middle, you can see a tiny little speck, and that's the space station that flew right in front of the partial eclipse at 1:14 p.m. Eastern Time. You can see it along the middle here, and there are some cloud coverage. You can see the clouds kind of going in front as well, but this is a really, really beautiful shot. The space station was traveling at about 5 miles per second here, so our NASA photographer, Joel, would have had about half a second to capture this exact moment. In Joel's photographs, you can also see like the slither of the moon at the top corner as well, and the moon was covering roughly 20% of the sun. Although Joel is a very experienced photographer, anyone can take photographs of a solar eclipse. So next, let's hear a few tips on how to photograph one. sometime after the show, NASA will also be releasing exclusive eclipse images from Spain as well. This is where our NASA photographer Bill Ingalls is hoping to capture the eclipse near the horizon. We're about 7 minutes away from totality in Leon, Spain, which is so exciting. This is some of the crowds there that we're seeing. You can see that the darkness is looming. It's not quite totality there yet, but they are almost there, which is awesome. So now I'm joined here by NASA's Heliophysics Director, Joe Westlake. Joe, how are you feeling about today's eclipse?
Oh, super excited. Super excited to see it and to share our science, NASA science across the world.
So if you're watching from the ground and you don't have eclipse glasses, there are actually many ways to watch an eclipse. These are through indirect viewing methods. So Joe, do you want to walk through some of those methods with us?
Yeah, so these are super cool. This is stuff that you've got at home and things that you can use to help you view an eclipse safely without your glasses. So here we have just a standard colander, right? What you would have in your kitchen. Maybe clean some, berries or whatnot with it. And I'm going to demonstrate how you would use this to look indirectly at an eclipse.
Okay.
You're using the light of the sun as it would filter through this colander. And let's demonstrate together. Here,
okay,
Joy. So yeah, if you could hold that.
Do you need a piece of paper?
You don't need a piece of paper.
Okay.
You can just have it on the ground, something light that you could see.
Okay.
I've got a flashlight that's sort of demonstrating what an eclipse would look like. It's got a little piece of foam there that'll show. So let's shine our light, let's do our sun, and then show it as it would hit this colander. And what you can see there is these nice little crescent moon shapes, which are showing the eclipse on our example paper here. So that would usually be a bunch of circles, like if you took this out during regular daylight. Here in the US, you would see just a little sliver gone. Over in Spain, of course, they would see these beautiful little crescent moon shapes.
So you don't want to be looking through the colander, but you want the sun to be shining through it.
Absolutely.
Okay.
Right.
Gotcha.
You want to use this as your light filter for you. And the cool thing is you can use this, but you don't have to use this. There's lots of other possibilities. So you can actually take your hands, right, like this.
Okay.
Spread your fingers out.
Yeah.
Hold them over top of each other. And you make little pinholes yourself when you do that, right? And when you do that, you can actually see through and be able to see the eclipse in the same way, right? So that's a cool way to do it. And then on top of that, let's say you're taking a walk in the woods. Well, the leaves of the trees actually make these kind of pinholes all over for you as well. When they do that, you get this beautiful, constant crescent moons and everything everywhere. One of my favorite ways to see an eclipse.
Thank you so much, Joe. And so today's eclipse, August 12th, also lands on another special day. So on this day in 2018, NASA's Parker Solar Probe launched into space to study the sun's corona up close. Joe, can you tell us a little bit about that mission?
Yeah, what an incredible mission. This is humanity's opportunity to actually touch our star, right? We flew a mission, Parker Solar Probe. It's still up there, it's still operating, it's still taking great science, but it's flying within the corona, within what you see in the total solar eclipse, and taking direct measurements of that corona to help us understand how our sun works.
Amazing. So we have a lot of questions coming in from social media, and we have time for just one, Joe. Great. So let's dig in. Kyle asks, it seems to be that there are a lot more solar eclipses happening the past few years. Did something change?
Nothing changed. The geometry of the sun, the moon, the earth is the same. But one of the cool things about our technological society today is you get to see many more of these things, whether it be because of social media, because of, people have access to cell phones, or just the accessibility of travel and being able to go to these different places. I'm personally really glad that people are hearing more and more about eclipses because it brings the greatness of NASA science home to all of you.
Thank you so much, Joe, for doing this demonstration and for being with us here today.
Thank you so much, Joy.
So now let's head back to the eclipse map where we're going to see the eclipse in real time. So as you can see in the bottom part of this video, the moon's shadow is just about to reach Spain. We're about 3 minutes out from totality hitting Spain. Leon, Spain is going to be experiencing totality, and it will be getting about 1 minute and about 44 seconds of totality, which is so exciting. The path is going to be hitting several other towns as well, such as Mallorca and Villalobado. And the view that we're seeing right now is of Leon, Spain. And even though totality hasn't occurred yet, you can see a tiny little filament, or prominence, sorry, on the one side. Okay, so remember to be safe when watching a solar eclipse. You have to be wearing safe solar viewing glasses or use an indirect viewing method when viewing when this moon hasn't completely covered the sun yet. You can only look at a total solar eclipse during totality when the moon is completely blocking the sun. So back in the studio, we have Kelly with us again. Kelly, what is it that makes this eclipse in Europe so special?
It really is so special because, again, this is almost at sunset. So we're experiencing something that's a little bit different, having it so low on the horizon. And look at those images there. You're seeing that darkness already coming in, those kind of sepia tones instead of the normal bright light or even the normal types of sunsets.
Wow, so we are 2 minutes away from totality in Spain. You can see the crowds in the bottom corner there, and this is the sun's view. Oh my goodness, so 2 minutes until totality, and we have a slither of the sun left. This is just amazing.
Yes, it's so beautiful. And like you were saying, there is that prominence there that we already see. So these are things that are very interesting and, again, can erupt in the space weather that we were talking about earlier. So this is a great view. And even with this, you know, it's not complete darkness. That little bit of sun still lights it up so that we can see the crowd.
Wow. So we're about a minute and a half away. What should people expect to see moments before totality hits?
So what they should see is what we call the diamond ring effects, or the Bailey's bead. So these will be really bright lights, and it's from the last bits of sun coming through the moon's valleys. So that will come through, and we'll see that. And you still need your eclipse glasses or an indirect viewing method at that point in time. But then once that's done and you're in the path of totality, it's time to remove those glasses and see the corona with your own eyes.
Wow. And if you're on the ground, what other sensations will you be feeling?
It will definitely be getting colder. There might be a wind. You could, again, change in animal behavior, any wildlife that's around you, and really the sense of awe, as well as the 360-degree sunset all around the horizon. So just a few things to look for.
Wow, this is a stunning, stunning view. We have just a slither left, and this is the moon covering the sun's disk. And when totality occurs, that slither will disappear. We're about 30 seconds away now from totality in Spain. If you're on the ground and you have clear skies, we are so happy for you.
Yes, definitely.
Wow.
It's just beautiful, and again, probably feeling so much excitement, and sometimes you even feel a little fear, like I think was mentioned earlier, they felt it was eerie almost. It's an eerie light. It's not something that we're used to in a human experience, but here it goes. We're getting close to those Bailey's beads, or the diamond ring effect, so those should be coming very shortly.
Wow. All right, totality is almost there. The slither is about to disappear.
Oh,
okay.
There's the little diamond ring.
Wow.
Yeah. All right.
Totality has hit Spain.
Yes.
Oh my goodness.
Lovely view.
What is the red mark that we're seeing on the image right now of the sun?
So the red mark is that filament. So it's a bunch of very hot material that has been hanging above the sun and just kind of hanging out there based on the magnetic fields of the sun that keeps it kind of in a little magnetic cage. Oh, look at that. That's a really nice view of the corona. You're seeing things that look like streaks coming out of this, and those are streamers. So that's the basis of the solar wind that we are bathed in constantly. The sun is constantly outflowing material, and so that's that constant stream, and then you see what could become a big chunk at some point in time in the pink filaments that you see there.
Wow. So we see that coming off of the sun. So this is the atmosphere of the sun's corona. Are those streaks that you just mentioned, are they coming towards Earth as well?
They are coming towards Earth. So they fill the entire solar system, or the heliosphere, which is actually all that the sun encompasses with that solar wind. So it's the entire solar system, so it definitely hits us here on Earth.
Wow.
And this is absolutely beautiful. Again, you're seeing a prominence also on both sides, really, and maybe even one up on the other corner.
Oh, wow, yeah.
So there's lots of, even though the sun is supposed to be towards a minimum of activity, which meaning you should see less of this, we're seeing more of it. And this is one of the important reasons why to keep studying these eclipses, is to see what is actually happening on our sun. When we think we know what's going on, it seems to change it up a little.
And what is it about these features that are so important to study?
It's important to study what they're made out of. Oh, and now we're back to the diamond ring. So we're coming back out of it already. It was always,
wow.
Yes, it happens so quickly. And once you see one, you definitely want to go back and see some more.
Wow. So totality has ended.
Yes.
In Villabado, Spain.
Mm-hmm.
Wow. So you're telling me that we also see the diamond ring and Bailey's beads at the end of the eclipse as well?
Yes, exactly.
Wow.
When you're going into or out of the eclipses.
Okay, so this is a view from Valoria La Buena in Spain as well. They are seeing an eclipse right now. Eclipses happening in Spain are about a minute apart from one another in these telescope views. So they're seeing totality. So the red mark that we're seeing right now, is that another prominence?
Yes, those are prominences, that material that is suspended above the sun that's very, very hot. Again, it's interesting to us to know what they're made out of. There's normally filters, like here and on the airplanes as well, to tell us about whether that's some iron or whether that's carbon or oxygen or what exactly is those pink filaments made of.
And you can see the moon is moving away from the sun right now. What is it that we're watching?
Yeah, Bailey's beads, and so these are the beads, and so now we're actually going out of totality again. So
wow, what a brief moment of totality. Yeah. This is just amazing. They have had clear skies, and this is exactly what you want for a total solar eclipse. Yeah. Wow. This is Mallorca in Spain. Yeah. Oh my goodness, this is stunning.
Wow, yeah.
Look at that corona. Why is it so much clearer? Why is the corona so much clearer during a total eclipse?
Yes, yeah. So it's so much clearer because you're taking away all the bright light from the face of the sun. The sun is very, very bright. So it's basically 1,000,000 times different. And when you blot out that middle, you can see all the beautiful things that are going on behind it. And so, yeah, so this is the beautiful crescent moon that you're seeing. I think previously we were seeing those strikes of light. That's also closer to sunset there as you go more south in Spain. And already the light's returning, and they seem to be very excited in the crowd there.
Yeah.
It's such a great feeling to experience those eclipses, even though they were so short.
Wow. And experiencing a total solar eclipse, that is completely different to a partial eclipse.
It really is. And it took me, even as a whole heliophysicist, it took me a while for them to convince me that I should do it. And once I saw my first in 2017, I've seen multiple since, because it is a full body experience. It is very different than seeing just one bite out of the moon. The whole body experience and just the joy and awe and kind of your place in the world is so important to experience.
Absolutely. I'm for sure now an eclipse chaser. Well, that was an incredible solar eclipse. What a view. I am thrilled that their skies were completely clear, which means that we could see the sun's corona so clearly. And we could even see multiple prominences as well from the sun, which is a beautiful sight during an eclipse. Yeah. So in a few minutes, we're going to be speaking with a NASA astronaut live from where they saw a total eclipse. But first, let's go back to the poll that we posed to you earlier on in the show. So, Kelly, I know that you had answered some of those questions as well. Yes. So let's take a look at what our viewers thought about those questions. Okay, so let's head to one of the poll questions. But while we're kind of like waiting to get that set up, let's continue looking at this beautiful partial eclipse now in Mallorca, Spain.
That's just gorgeous. That is just absolutely gorgeous in terms of that very little sliver. Again, this is towards sunset. So normally if you're looking at a sunset, especially over water, you're seeing that kind of orange ball, red ball go down, and then you have this beautiful eclipse to happen. These really are just going to be spectacular images.
Yes, absolutely. Okay, so let's head back to the poll answers. Our viewers, so the first question was, where would you rather watch an eclipse from? You said the International Space Station, and our viewers would agree.
Yes, it'll be a party on the International Space Station.
I also wanted to be there too, so we're all going to be up there. The second question on the poll for everyone watching was, what would be your ideal eclipse watching soundtrack? And the options were cosmic lo-fi beats, dramatic space opera music, chill acoustic sky watching vibes, or just the sounds of nature and the crowds. And the winner was cosmic lo-fi beats.
Oh, all right. Yeah, that's a good soundtrack. I can see that.
Yeah. I voted for opera music, but
yeah, and I might be a little bit more Sounds of Nature, but that's just me.
Okay. Well, anyway, thank you so much. So, although totality is over, the partial eclipse will still be visible for the next hour or so. Remember to stay safe while watching the rest of the partial eclipse by wearing eclipse glasses or by using an indirect viewing method. And so if you want to learn more about eclipse safety, go to science.nasa.gov/eclipses. Okay, so next we have a very special guest calling into the show live. NASA astronaut Don Pettit just witnessed the total solar eclipse from Alcañiz, Spain. Don, can you hear me? How are you doing?
I can hear you loud and clear, and I'm standing out in Alcañiz, Spain, just in awe from looking at the totality phase of this eclipse.
Wow, so how are you feeling? I know you just finished watching the eclipse. How are you feeling right now? What did you experience on the ground, and what did you hear? Were you surrounded by crowds at all?
The sky is exceptionally clear, and there's hundreds of people here, and that's part of the eclipse. It's not being off by yourself, it's being with a group of people, the people that live in Alcañiz, the group of people that I'm here with, and experiencing this amazing celestial event all together.
Amazing. So people might know you for your incredible photos and videos from your multiple trips to the International Space Station. Did you take any photos during this eclipse, or did you put your camera down for this one?
Oh, no. What I do is the same thing for launches. You set a camera up on automatic, and you get whatever you get from the camera, and then you stand back and you watch the launch or you watch the total eclipse. They're both kind of in the same category in that they only last a couple minutes in terms of what you could see, and it's better to view them through your own two eyes than through the viewfinder on a camera.
Okay, good tip from a NASA astronaut. So how did the experience watching this from the ground compare to watching an eclipse from space, which I know you've done a few times?
I've had the opportunity to see two solar eclipses from space. And in space, you look at the shadow projected on Earth. You don't look at the sun itself. And the shadow has all the detail that the classic astronomers from hundreds of years ago predicted. You see the umbra, you see the penumbra, you see the shadow moving over Earth, and it's a vantage point from space that you can't see from Earth.
Wow. So lucky. And I know you've seen a lot of other beautiful phenomena in space, like the aurora and air glow. What is it that makes watching a total eclipse special for you?
It's the whole package that comes with a total eclipse. It's the shadow phenomena that happens around you. It's looking at the corona around the sun. It's experiencing the reaction of all the people you're watching it with. So it's a human emotional event as well as much physics and natural phenomenology as you want to add to the mix.
Wow. Well, thank you so much, John. Any parting words?
Just get out and watch an eclipse, whether it's a total eclipse or a partial eclipse. They happen. Lunar eclipses happen. Get out and look up at the sky and think about what's going on and smile.
Thank you so much for joining us live from Spain. We're so grateful you could share your absolutely amazing solar eclipse experience with us.
You all take care.
Wow, Kelly, it's amazing to hear someone as passionate and knowledgeable as Don.
Yes, it really is, that he's seen so much and he still is so passionate about the eclipse here on Earth. It just really tells you have to see this thing.
Absolutely. So if you're looking to catch the next total eclipse, you're in luck because we have a few special ones coming up. Kelly, can you run through them with us?
Yes. So next year there is going to be an eclipse that happens in part of Spain, throughout the northern Africa, through the Middle East, and that's going to be the eclipse of the century, the longest one of the century. So it's 6 minutes and 28 seconds. That's going to be a very long one. And then in 28, we're going to have the eclipse over Australia and New Zealand. So these are going to be great scientific experiments as well as amazing experiences to experience on the ground.
Amazing. And what about the United States?
The United States, well, the next one where we'll have totality is 2044 in Montana and North Dakota, and then 2045. So it's going to be a while before we go California through Florida across the entire continent.
Amazing. So if you want to learn more about solar eclipses and NASA science, you can head to science.nasa.gov/eclipses. So Kelly, thank you so much for joining us in the studio today and answering all of our questions from our viewers. I also want to thank our guests who joined us in the studio and on the ground as well, and especially to our telescope partners and everyone who looked up with us here today. And so I think we may have some eclipse pictures from the International Space Station. I'm going to see if we can grab them now for you. If you can't, we'll be releasing them shortly after the eclipse. We're going to be posting them online soon after the eclipse, but yes, we're happy that the space station astronauts were able to see the eclipse from space. So we have something else exciting happening in just a few weeks. NASA's Kennedy Space Center Launch Complex in Florida will become the next launch site for the Nancy Grace Roman Space Telescope. This is a one-of-a-kind observatory that will help answer essential questions about dark energy, exoplanets, and much more about our solar system and out to the observable universe. The launch is currently no earlier than Sunday, August 30th. We're so excited for you to join us next time as we follow another historic mission in space exploration.
Every discovery begins with a new way of seeing. NASA's Nancy Grace Roman Space Telescope will reveal the universe on an unprecedented scale. With its powerful, wide-eyed view, Roman will map vast regions of the cosmos, seek the hidden influence of dark matter, and uncover the mysterious force driving the universe's expansion. With a wider view comes a deeper understanding.